Greetings and welcome, friends. Mr. Waddy here. We are taking a look at 7.4 properties of special parallelograms. We learned about a variety of them yesterday. You've seen all of these shapes before, but maybe you didn't realize they family. They are family with one another. It's wonderful, wonderful. Page 392 is where we're at. Going to answer some of your questions, I hope. Please, students in real life, please be willing to engage and participate in the conversation, ask questions, correct me when I'm wrong, because we all know that happens. It says, for any rhombus, JKLM, let's see, I'm just going to draw an arbitrary, poorly drawn JKLM rhombus. It would be labeled in the order of those letters, just like when we label a triangle. So yeah, good question. Oh, as long as it's, I could rotate this any number of ways, but the letters should in sequence, like K needs to be between J and L in sequence. All right, if that answers the question. Good question, though. Let's see, question 3. It says, determine whether the statement is always or sometimes true. Draw a diagram to explain your reasoning. L congruent to M. How often are these going to be congruent? All the time? Some of the time? None of the time? What are you thinking? Yeah. Well, we know that opposite angles are going to be congruent because of rhombus is a type of parallelogram. But, yeah, but as far as these two adjacent ones, I think we'd put this in the sometimes category. All right, adjacent angles are going to be supplementary to one another. That's a property of parallelograms. When would they be congruent to each other? What type of shape? So for squares, when it gains the rectangular property of having 4 right angles. How about JM congruent to KL? JM and KL, that's just always. Always. By definition of a rhombus, that's always going to be true. Yeah, it's made up of 4 congruent sides. All right, classify the quadrilad. Explain your reasoning. So I've got, all right, 4 congruent angles and 4 congruent sides. The 4 congruent sides, it's in the rhombus family. But the 4 congruent angles, they don't tell me the measure of those angles, but what do they all add up to be? If those are all x degree angles, I would have 4x equals 360, divide both sides by 4, I believe I get x equals 90. And so that puts it in the rectangular family, and most specifically, it would then be a square. Okay? Yeah, even though those weren't labeled as 90 degrees, I was able to do a little bit of work to figure that out. Okay. All right, is this even a parallelogram? For this question 11? Well, I've got these 2 right angles that are adjacent. We do know that these sides are parallel because 2 segments or sides parallel to the same side are going to be parallel to each other. I also know that those same 2 sides are congruent. I believe we had a way of proving a quadrilateral was a parallelogram when you had 1 pair of opposite sides parallel and congruent. So it's at least a parallelogram. Since it's a parallelogram, I know that consecutive angles will add up to 180. All right, so this 90-degree angle and this 90-degree angle clearly do. And this 90-degree angle and this unknown angle have to add up to 180. So these are actually both going to be 90-degree angles as well, putting us in the family of rectangle. Yeah? You guys agree, disagree? All right, I like that problem. I like that. Also, I like these little pictures. Yeah, you guys like those pictures? I don't know. You probably couldn't really tell what was going on with them with your black and white. Question 15. Find the measures of the numbered angles in rhombus DEFG. So, lots of angles floating around. Let's see. If this is a rhombus, that means these are all congruent. What else do I know since it's a rhombus? I know that, okay, because a rhombus is a type of parallelogram, I know that 4 and 2 are going to be congruent because those are alternate interior angles. What else do I know? Anybody? Why are 4 and 3 congruent? We had a property yesterday that said what? The diagonal of a rhombus, what's it do? It bisects the opposite angles. So so that means 4 and 3 are going to be congruent. 1 and 2 are going to be congruent. I agree. Let's see. How about this 106 degree angle? Why is that true? And that's because it's a parallelogram. We didn't even need to know it was a rhombus to know that angle 5 was that. So let's see. Okay, so if this is 106, 1 and 2 combined are going to be supplementary with 106. So 1 and 2 add up to be 74. And 1 and 2 are congruent. So what's 74 divided by 2? 37. Okay, so that's going to be true for angle 1, angle 2, angle 3. Right, you also could have done that, I guess, with, you know, the fact that, what was that, the corollary of the polygon interior angles theorem? That for a quadrilateral, that all the interior angles would add up to 360. There's a few ways you could have come across this. I use the fact that consecutive angles in a parallelogram are supplemental. So measure of angle 4, those are all 37 degrees. And then angle 5 is 106. All right? Yeah, you guys with me on that? Yeah, that's like just a sad looking 6. There we go. I'm actually pretty happy with that degree symbol there, though. That one in particular. Let's see. Oh, man, guys, I like these. All right. Determine whether the quadrilateral is a rectangle. Anyone have thoughts on 23? What do we got? Who's thinking? All right. We've got one confused on this. Anyone who's like pro-rectangle? No one's pro-rectangle. Whoa. Anyone anti-rectangle? Or, okay. Pro just regular quadrilateral on this. Okay. All right. Well, let me ask you this. So it is a quad. Is it a parallelogram? Yes. All right. You guys can give me verbal responses if you want, but I'm fine with a thumbs up. It is a parallelogram because opposite angles are congruent. I actually don't know consecutiveness or supplemental. I don't know whether or not those are supplementary. So it is a parallelogram. Can I narrow that down? Do I know whether or not these are 90-degree angles? I don't. So I'm going to say not a rectangle. Not a rectangle. I don't think it's possible. Not with a given information, right? And what is the definition of a rectangle? 4 right angles. A quadrilateral with 4 right angles. That's a sad rectangle, but I realized my box around that answer was almost rectangular. Last question. All right, find the lengths of the diagonals of rectangle. Let's label this in the order that it's given with my saddest looking rectangle. I think I left my rectangle out in the rain and now it's all soggy. Oh, this one right there? All right, yeah. Actually, this looks pretty perpendicular right there too. But the rest of it is, man, like Squidward living in a box. Let's see, W, X, Y, Z. So WY. Oh, we're talking diagonals here. Okay, W to Y is this, and X to Z is that. What do I know about the diagonals of a rectangle? They are congruent. Their measures are equal. Yeah, so this is just the classic. They threw some algebra into a geometry problem. Who put their algebra in my geometry? Right, that's like the... Let's see. And then, yeah, you guys are master algebraticians. Miss Hillo represent, right? She prepped you. Actually, yeah, I don't know that. Yeah, I'm assuming maybe not all of us have. Wow, that's a statistical anomaly. I wonder what the cause of that is. So x equals 3 is the value of x. Now, they didn't ask us for the value of x. What did they ask us for? The lengths of the diagonals, the classic switcheroo right at the end where you think you have the answer, but you don't, in fact. So let's see. If I want to find wy, what could I do? Yeah, just plug x in. Right there. Plug x in So I'm going to have 6 times 3 minus 7. That's 18 minus 7. That's 11, my friends. And both of those diagonals are congruent. So I'm going to say wy is equal to that, as well as xz. Bam. All right, thanks for watching, friends. Bye-bye.